but he wanted everyone to be able to get to it, all his colleagues, from wherever they were at and whatever computer they were using. So he invented something that was designed to mimic Apple technology. Okay? Now, the details of how that all came together quickly became nothing like Apple technology. But I've read papers where he said that was part of his inspiration. Okay? It wasn't a Bill Gates product that he was trying to mimic. Okay? So, the web comes along and gives us this ability. And quickly people realized, once we made it, you may not know this, but before about 1991, you could not do commercial business on the internet. Okay? It was a research academic system only. Okay? In fact, if you were sending business email, you were supposed to send it a different way. But then they made it available to the general public, because basically everyone was using it anyway. Okay? But then, what is it, 93 or 94 that Amazon gets started? Jeff Bezos' business? And so the web server, it turns out the original web servers weren't built anything like we build them today. Okay? Because the original web servers were supposed to actually just help academics share papers and stuff like that, which is not e-commerce, is it? So it turned out that web servers combined with e-commerce was the killer app that actually drove the concept of a thread into mainstream. They existed before, but mostly just for people doing supercomputer work. Okay? All right. So threads have been around for a long, long time. There had been just key threads existed from the early 1980s. People were writing their own threads as far back as the 1960s. But they were all doing it customized on their own, and there wasn't a general tool available in computer science, and very few people in industry saw a reason to actually use threads. And then e-commerce came along. Okay? So I like to give this idea of the benefit of threads in the context of web server generation, okay, the generations of web servers, how we went from one technology to the next, and point out that if this didn't happen, Jeff Bezos would still be working out of his garage in Seattle. Okay? This technology needed to occur in order for us to have the e-commerce world that we're in today. Okay? So I'm not saying that Jeff Bezos would not exist without this. It'd be very, very hard. But the way we expect the web to work today, which is quick and fast, wouldn't exist without this approach. Okay? So it is the killer app. It's really quite cool. In the early days, there's some orange container down there. I don't know whose that might be. In the early days of the web server was Mozilla. And that's the only one we have. And the way it ran was it's a single process with a single thread. So someone connected to it, okay, using the get HTTP, yada, yada, yada stuff. And you go to the web server and it would say, hey, get me this research paper. And then it would go off, get the research paper, come back, ship it off to the person that wanted it. Okay? It's a simplified view. But while it was getting that paper and shipping it off, no one else could connect to the web server. But that was okay because, to be perfectly honest with you, there's not millions and millions of people wandering around trying to get hold of research papers at any one point in time. All right? No matter how popular the research was. Okay. So it didn't seem to be a problem. But if you start thinking about this, maybe you've got something like a conference coming up. And it might be a huge conference. So like Comdex. Has anyone ever heard of Comdex? Which is the largest computing technology. I don't know if it's still called that, but for years it occurred every October, and it had tens of thousands of people that went to it. Okay, and in the 2 days before the conference started, everybody wanted to go there and get the updated schedule. Okay, But now we got tens of thousands of people who only one person can get it at a time, so only one web service per about 10 seconds. So if you're the second one, you get to wait 10 seconds. If you're the 10,000th person you're all trying to connect to at once, guess how long you get to wait? 100,000 seconds. Okay. If you guys went to Amazon and you said, go to Amazon.com, or for me, smile.amazon.com, and it took 10,000 seconds before it replied, would you buy from Amazon? Or would you go down to Walmart? Because that's basically what was happening at the time. Amazon was trying to get people away from brick and mortars. Okay. So it turned out that by having slow response time, that is high latency, it turned out that e-commerce did not map to the web at all. Lots of places tried, lots of places went under. AOL put their own virtual shopping mall concept up. It failed. Okay, and I think it failed primarily. I was around at the time. I think it failed primarily because things were so slow. It was so frustrating using it that you'd use it once or twice, and unless you were desperate, you never went back. Okay.
Back then, wasn't it really sketchy to use your credit card
I
online?
can't quite hear you, Zach.
Back then, wasn't it really sketchy to use your credit card online too?
It's we're just not going to go there.
Still is.
All right. To a certain degree, it still is. All right. And that's a security course or a discussion outside of class, because I used to teach all the security courses here. And I consult in that area, and Amazon is one of my clients, and I'd be happy to talk to you about what that is. And the vulnerabilities just got worse with the web. It's all vulnerabilities that existed before. Because how many of you have ever used your credit card someplace like a Target store, and then suddenly you get an email that says, oh, by the way, all your credit card details were stolen. That wasn't over the internet. Okay? Point of sale skimming of credit card stuff has existed since the late 1970s as a full-time business. I testify in that area on the technology. So we have this issue here. We're going to do one thing at a time. And that was the original design, because that was the technology we had. Okay? But not quite. It turned out that there was some other technology that was hanging out there, but it wasn't first and foremost in programmers' minds. So then they came along and said, oh, we need to be able to do many things at the same time. That is, we need to be able to do them concurrently. Okay? So we said, how can we do that? So then we came along and they said, well, if we get a second connection, why don't we just run fork and create a new process? Seems straightforward. We have that technology. Just call fork. What we'll do is there will be a small program that sits at the front, looks at the network, connection comes in, it forks a copy of the web server, hands off the connection, off it goes. Logically, that's what we want to do. But it's even slower. Why? In order to fork, we have to copy everything. Okay? Do you think when we start a new connection for somebody coming in, let's say it's Amazon, let's just figure out how Jeff Bezos became as rich as he is, in case it rubs off on us. Okay? Do you think that they run the same code? Those web browsers?
No.
Yeah, it's the exact same code. The exact same code. We fork. We don't fork an exec. We fork. And we run that web browser. Okay? That might be 30 megabytes of code that we have to copy 4 bytes at a time. Fast or slow? But then there's the state of all the images and all that kind of stuff that we display when the browser displays the home page, right? We've got to copy that too. So you might have, I don't know, back then we tried to keep them small. The code wasn't, massive, about 30 megabytes or something. It's probably around 4 to 5 megabytes. But you probably had a 10 megabyte process. But also back then, 100 megabytes was considered a large memory, 128 megabytes. Okay. You might have to buy a super big server that had a gigabyte of memory. And that would be expensive back then. So now, the only two differences between these two instances of the web server is the state for the connection that they're servicing. Okay? And that's state that's private to that transaction, isn't it? The rest of it is generic to the web server. And people went, well, this is technology we know, but if I only have 150 megabytes or 128 megabytes on this system, how many connections can I have before I run out of memory? And the answer is not many. You have more than one. So it was an improvement. And then somebody said, well, I want more connections. And people started saying, well, we need huge memories. And one of the supercomputer guys came along and said, no, you don't. Just use threads. Somebody went, what? So they went off and investigated threads. And all of a sudden, it was as though the clouds parted, the sun came down, the angels were singing. Okay? Because now we can run multiple threads of control in one process. When we create a new thread, we don't copy the process because the thread is created within the existing process. We only create a few tens of kilobytes, maybe 100 kilobytes of new data. Okay? 100 megabytes. How many 100 kilobyte pieces of data can we have there versus web servers? More or less? Let's just go with more. Okay, and it's more with a capital M. Sometimes the rest of it's capitalized as well, and there's 2 exclamation points at the end. Okay? So all of a sudden now, we can listen for multiple connections, can't we? And service them independently. And that's what we started doing. And that's one thread model. Okay? So each one says, okay, you're busy, I'll go off and look at the network now. As soon as I get that, I'll service that request and I'll come back. And logically, that's the way it works today, except we can get even better performance. So at this point, we've got threads, we're using our memory really, really well. How can we get speed, raw speed? Okay. And that's how do we use our threads. So now what we've got is most web servers are going to use something along the lines of a manager worker thing, approach, which is we have one thread out there now, or a small group of threads, a thread pool, listening for connections off the internet. When it gets a connection, it sticks that information on a queue. And then we have a whole bunch of threads that go off there and go and look at it and go, give me the next one, give me the next one, give me the next one. If there's nothing there, it just goes, oh, sucks to be me. But when something shows off, it goes off and happily does that. If all of a sudden the queue gets really, really big because something's going on, Black Friday, Cyber Monday, all we have to do is create more threads, don't we? Dynamically create more threads, we can handle more connections simultaneously. And if we have a virtual CPU, we can add more virtual processors. Okay? And everything dynamically scales without us changing our code. Because threads will naturally scale to the number of processors or cores. And that's how web servers work today. One process. Specialized threads. Okay? So the thread that actually goes, when you click buy, there's a thread that puts things into your shopping cart. Okay? Then you click purchase, and it's a different thread that's going to go off and talk to the credit card company. very specialized threads. So those threads can do one job and one job only, do it very, very well, and it's easier to debug. Unless you have to worry about all the threads running together.
Is that type of threading somehow related to processor paper threading at all?
So threading the way we're talking about it is a different technology than CPU hyperthreading. The concepts at a very, very high level are similar, but that's really how does the operating system map these kind of threads down onto a CPU that also understands a different type of thread. So at that point, we have multi-threads mapping to multi-threads.
Right.
And so that gives us huge performance wins, but it's quite complex. And that's a very low level, very advanced programming technique. Although there are people in town who are very, very good at it, because Linux has to do that. And a lot of the parallel architects for memory and things like that are in town. Even Linus is in town. So that's threads. That's finish up our threads. Here's a bunch of thread links. I just threw those out there. By the way, these lecture notes are really, to be perfectly honest with you, just for me. But I give them to you guys so you can see what I'm going to talk about. So what I'm doing with this is I'm just writing down what I'm going to say anyway. The POSIX thread programming at Lawrence Livermore National Labs, LR now, almost everybody who moves into thread programming or supercomputing programming are told to go there and do the tutorial. If you go to work for Lawrence Livermore National Labs, the first thing you're supposed to do in the first week or two is do that tutorial. That's your job. Teach yourself threads. There's a book, Programming POSIX Threads. It's a few years old now, but it's still one of the best books around. Okay? YoLinux has a tutorial. I looked at that. I found it a couple weeks ago, and I looked at it and was like, wow, that actually is really accessible. Makes a lot of sense. The book from CS201 has a chapter on multi-programming and multi-threading, chapter 12. We don't cover that in CS201, but if you still have the book, you can look at that, give you some bunch of information. Also, the book is on reserve in the library every term that we teach CS201, which is almost every term. Now, those are good ways to understand the basics of threads. I'm not asking you to read them. You do not have to read them. If you're interested, the way we're going to talk about threads of control in this class, we're going to use a process is going to have one thread. So we're not going to be talking about the subtleties of multi-threading. The operating system appears to be multi-threaded because of the way it works. Okay, so we will see threading issues. It's just that we won't be programming in P threads or something like that. Now, how many of you have ever used Linux? Just out of curiosity. Did you guys know that Linux is massively parallel? And it turns out they have a book